Tonight on Nova, it's a stunning opportunity for solar astronomers, a total eclipse of the sun.
We got prominences the size of a Buick.
In 1991, Hawaii affords the best chance yet to see behind the sizzle and understand our closest star. Will the eclipse tell all?
Oh shoot, the cloud's covering it up.
Or will a cloudy day in paradise wreck the eclipse of the century?
Funding for NOVA's 20th anniversary season is made possible by Lockheed, America's aerospace company, supporting math, science, and engineering education for national technology leadership. And Johnson & Johnson, the signature recognized around the world for commitment to quality healthcare products for the entire family. Major funding for NOVA is provided by the Corporation for Public Broadcasting and by annual financial support from viewers like you.
It is early July 1991. The place is the Big Island of Hawaii, a land blessed by the sun. But this week, 20,000 people are pouring in, not to worship the sun, but to watch it disappear. This is the year of the great Hawaiian solar eclipse. In recent years, eclipses have become a kind of carnival, and this one is no exception.
Stockstill for helping to put this all together. Thank you from the Hyatt Regency Waikoloa.
But the Hawaiian eclipse is more than a tourist spectacle. For solar scientists, it is the chance of a lifetime.
Thank you very much for being with us this morning.
An accident of geography makes the difference. This is Mauna Kea, at 13,800 feet, the highest peak in the Pacific. On its summit ridge stand some of the most important astronomical observatories in the world. The telescopes here explore the deepest reaches of the night sky, searching for black holes, distant galaxies, curious stars. But at 7:28 a.m. on July 11, 1991, these telescopes will point directly at the sun, the nearest star of them all. This is the first time that an eclipse will occur over such a major observatory. Astronomers have come from around the world to peer into the mysteries that can be seen only during the 4 minutes when sun and moon meet.
It's interesting, I'm a solar astronomer, and the only time everyone gets interested in the sun is when the moon blocks it out and we can't see it anymore.
But that perfect overlap of sun and moon is the result of a remarkable coincidence. The moon is 400 times smaller than the sun, but it is also 400 times closer to us, so that both moon and sun seem to be virtually the same size when seen from the Earth, a fluke of orbital geometry that occurs nowhere else in the solar system. An eclipse begins at what is called first contact, as the moon begins to pass directly between the Earth and the Sun. The eclipse continues to second contact, the beginning of totality, when the lunar disk completely covers the Sun. The wispy corona, or solar atmosphere, appears for the few minutes of the total phase. That corona disappears when the moon uncovers the edge of the Sun, with partial eclipse continuing for about 1 hour. The perfect alignment of Sun, Earth, and Moon occurs about once every 18 months. When it does, the moon casts its shadow over a narrow strip of the Earth's surface, the path of totality. In July 1991, it is Hawaii's turn. But an eclipse is a one-shot deal, where anything can go wrong. In 1937, an eclipse at the top of the Andes enticed scientists to construct an elaborate temporary observatory. But eclipse day itself was almost clouded out. And while the weather can always turn foul at the crucial moment, human error poses just as large a threat. Scientists came to the Mauritanian desert to study an eclipse in 1973. But the Sun and Moon do not wait while things go wrong.
Pac-Man, where's the drill again?
This time, an equipment failure just minutes before totality was repaired with seconds to spare.
Talk about being close.
10 seconds! 9, 8, 7, 6, and 5, and 4, and 3 Bailey's beads! Totality!
Eclipses come on with a lot of urgency, and there are a lot of tales about them. Things always go wrong. There are last-minute changes. I think one of the funniest was a message that came back from an eclipse expedition in Puka Puka, I think it was, about 25 years ago, where the observatory back home is waiting for word, how's it going? The simple message came back, delay eclipse 7 days, send more kaopectate.
The Hawaiian eclipse presents the same risks. But the once-in-a-lifetime chance to use these telescopes makes failure for any reason more costly. Already there are rumors of approaching bad weather, and the pressures of beating the eclipse deadline boosts the odds that something will go wrong. For one team, it already has.
Even if it doesn't work at all, we're not going to tear our hair out because
You pay your money, you take your chances, you know.
Yeah.
You do the best job you can. It's not the first time something like this has happened. We'll be disappointed if we don't get data, but we're going to see the eclipse one way or the other.
5 days to go. The NASA scientists have just arrived at their telescope, and already there's a crisis. Their crucial piece of equipment has broken. Named Celeste for Babar's Elephant Queen, it does not share its namesake's good nature. Drake Deming explains.
This is a problem. We've seen it before. It's intermittent. It's never been a problem long enough that we could isolate it and fix it. But we can't run this way. So we have to hope that the problem stays a problem, and it so far it has. Find the problem by going in and basically the first thing we'll do is we'll just jiggle wires and see if there's something loose.
In Celeste's case, if it ain't broke, they can't fix it.
Oh, I see what the problem is. Well, the wires are disconnected. It's a lot like open heart surgery, I would say.
Still not working.
All right.
Yay, it's broken.
Mauna Kea itself makes their work more difficult, as the harsh conditions of high altitude take their toll on all the eclipse observers.
Whoa, Nellie.
At the University of Hawaii Observatory, Barry Labonte.
Well, you know, the lack of oxygen is not so bad, and the low temperature is not so bad, and the funny hours is not so bad, and the long, terrible road is not so bad, but you pile them all up and it kind of adds insult to injury. So that's it makes things a little tough. The first couple days are hardest. It's hard to get acclimated.
But there is no time to spare, and the stakes are high. A single slip can wipe out years of work.
We were preparing almost 2 years for 2-3 3-4 minutes of observations, of good observations. During few minutes, probably 5 minutes, this will be the largest optical solar telescope in the world.
And aiming it at the eclipse will be the culmination of a scientific career. But the eclipse is just the first step for some young scientists.
The tripod weighs 1 million pounds, I swear to God, it's so heavy.
Anna Correa is a high school freshman from Massachusetts. She won a national contest to come here, and like the professionals atop Mauna Kea, she will take her chances on Eclipse Day.
Probably, because they keep saying the safest way to watch it is on TV.
What isn't safe is to point a deep space nighttime telescope directly at the sun. The Mauna Kea telescopes offer a unique view of the eclipse, but to use them, the observers must overcome obstacles conventional astronomers never face. At the Caltech radio telescope, Hal Zirin's team has had to find a homemade solution to the problem of protecting an instrument that was never designed to aim at the sun.
This telescope was really not built for looking at the sun. It was built for looking at stars in formation and clouds of gas around stars. And that's why we've had to cover it up with this big tent, because it's so darn sensitive that if we pointed it directly at the sun, it would burn up the secondary mirror. So we've had to be very, very careful with what we do.
There is only one difficulty with the custom filter. The tent came out of the workshop one size too small. But Zirin's team came up with a simple fix.
Around once. There's that one. Listen, boy, this shows the advantages of a Harvard education. You really learn how to do this stuff. I think that's all right. We need more foam balls.
The Caltech telescope is now ready to explore one of the fundamental mysteries of how the sun works. To the naked eye, the sun appears to be uniform and unchanging. But viewed with modern instruments, the sun shudders with violence. A fusion furnace in the solar core generates the sun's energy, its heat and light. As it rotates, the sun also acts like a giant electric power plant, generating an intense tangle of magnetic fields. At the surface of the sun, magnetic fields explode into space, dragging with them hot, electrically charged gas, solar prominences, and flares. At their most violent, such magnetic storms can touch the Earth itself. Giant solar flares trigger the aurora borealis, the northern lights. And magnetic storms can wreak havoc as well. Hydropower might seem immune to explosions on the sun, but in 1989, a giant solar flare tripped the voltage regulators on Quebec's power grid. The province was blacked out for 9 hours. The behavior of these magnetic storms poses a problem for solar physicists, one the eclipse may help to solve.
The sun has a remarkable temperature structure, which probably is true in many other stars. The surface temperature is 6,000 degrees Kelvin, or about 10,000 degrees Fahrenheit, pretty hot, and then it goes down a little bit more in temperature, and then it suddenly rockets upward, so that the solar corona, the part of the sun that we see during totality when the moon covers the rest of the sun, is 1,000,000 degrees.
The jump happens between here and here. Something is going on between these 2 points. The question is, what?
We don't understand this phenomenon, which happens in so many stars, and there it is in front of us, and nobody's been able to explain it, because you can't heat a 1,000,000 degree thing out of a 6,000 degree thing. It's crazy.
Crazy or not, the explanation seems to lie with the sun's magnetic field. One theory proposes that little explosions, called microflares, spark continuously at magnetically active regions, pouring out the heat that could warm up the corona. But the glare of the sun hides the corona and any such tiny explosions. The Hawaiian eclipse will give astronomers their first chance to explore the impact of these magnetic fields on the corona with the power of the big telescopes. Zirin's team will look here to draw the first detailed temperature map of the area just above the surface of the sun.
All we'll know then is what exists on the sun, but then we can go back and try to explain it, because a lot of times we're trying to explain stuff that we don't even know what it really is. So here we're just trying to get the facts, and then we'll look at the facts and try to understand them.
In the 4 minutes and 8 seconds of totality, each of these telescopes will explore a different region of the sun, a different piece of the solar puzzle. It is a chance that will not come again. Four days to go. With her experiment ready, Anna Correa is ahead of the game in her first experience of original science.
Well, this year was one of my first years really getting into science because of my teacher. He really pushed hard on us, especially because science used to be my worst subject. I mean, science was, when I was in elementary school, it was easy, but then it got harder, and now it's just, I don't know, I feel interested in it.
The plan is to photograph the moon every 10 seconds as it crosses the sun during the eclipse. Anna will then use the apparent motion of the moon to calculate the speed of the Earth's rotation.
We were just trying to figure out something that nobody would do. It could be possible that I can discover something with this project of mine that hasn't been discovered before. So, who knows?
Fais ce qu'on a pu.
Oui, c'est bien.
Tu vas trouver ça si tu te levais du
c'est
faisceau,
bien,
tu vois.
C'est bien ça. C'est magnifique.
Quelle surprise.
While Anna begins her scientific career, Serge Kuchmy has 25 years of eclipse experiments behind him. This time, Kuchmy will place 4 cameras on the Canada-France-Hawaii telescope. 2 of his cameras will shoot film, and 2 will record video. They will take pictures continuously throughout the 4 minutes of totality, looking for evidence of magnetic heating in the corona at the finest level of detail. As magnetic fields tangle above the surface of the sun, the gases of the corona form shapes and structures which these cameras will record. The Canada-France-Hawaii team will look here, taking what they hope will be the best high-resolution photographs ever made of the sun's magnetic field in action. The Earth basks in this constant flow of solar magnetism. Solar energy powers the winds, keeping the atmosphere in constant motion. But the sun seems to alter its energy output, with profound consequences for life on Earth. Magnetic fields erupt from the sun at dark blemishes, sunspots, and there appears to be a link between sunspots and the Earth's climate. Beginning about 1650, the northern hemisphere was gripped by a prolonged chill called the Little Ice Age. For almost a century, the solar magnetic field was quiet. Sunspots virtually disappeared from the sun. Around 1715, sunspots reappeared, and in time, the ice began to melt. The northern hemisphere began to warm. What makes the solar magnetic field so fickle? That is the ultimate question behind all the Mauna Kea experiments. Why it is that the sun that seems so constant changes so capriciously. Three days to go. The pre-dawn glow catches the NASA scientists after a sleepless night, still working to save their eclipse experiment. They have fixed Celeste, they think, by replacing its defective circuitry. The instrument must now be cooled with liquid helium to shield it from any stray heat that could interfere with the signals from the telescope.
Careful you don't get it iced into there. This is the most fun. Unless there's a leak, and then this isn't fun at all.
This is where we become apprehensive, because when the door is finally cold, we first find out whether we can actually operate. Right now it looks like everything's working.
When placed on the NASA telescope, this instrument will analyze signals from the sun. Celeste works like a prism, breaking up the sun's light into all of its component colors. For the eclipse experiment, Celeste will look in the infrared, what we feel as heat. Within the infrared, Celeste will seek a particular wavelength, one which has a uniquely valuable property. This single line splits into three at an active magnetic region like a sunspot. The width of the split reveals the intensity of the magnetic field. During the eclipse, Celeste will look for the wavelength in the solar atmosphere, and the NASA experiment is designed to locate exactly where it can be seen. The NASA team will look here for their wavelength. If they find it, they can use the line to gauge the strength of the magnetic fields that could heat the corona. But that's only if Celeste gets ready on time.
We were launching the space shuttle. We would have a hold in the countdown. And a few days, we would fix it and launch it later. We can't do that for the eclipse.
Celeste will take more than a day to reach its operating temperature of 6 degrees above absolute zero.
I hope we get on Saturn tonight. That's really cold.
It's a costly delay, but not a disaster. Not yet.
Is that the way Donald Duck would sound at a solar eclipse?
I guess that's the way he sounds.
But while the NASA scientists work on, daybreak brings with it troubling news. Cirrus clouds are building up in the eastern sky, just where the eclipse itself will be seen. The last 10 July 11ths have been clear, but there are no guarantees. Inside the University of Hawaii Observatory, Barry Labonte begins his day with a final equipment check before attaching his instrument to the telescope.
Sure, we have here is a camera, but it's a little fancier and uglier and bigger and has more parts in it than your normal camera. And in fact, in here we have 3 separate cameras that will give us a variety of different looks at the corona. They sense the light and convert it directly into electrical signals that then are sent into the computer. I brought the spare ones up my brief.
Labonte's team also wants to know how magnetic fields could heat the corona. But for all their high technology, the experiment here draws on the early history of eclipse science.
Back, it's stapled.
Okay. Cutter. Cut it.
Scientists since Newton have known that ordinary sunlight can be broken up into the colors of the rainbow, the spectrum of visible light. By the mid-19th century, it was known that chemical elements produce characteristic colors. Copper burns green, and here sodium produces its familiar streetlight yellow. Using a spectroscope, essentially an eyepiece, a prism, and a slit, it became possible to dissect light to search for chemical elements. white light produces the continuous rainbow spectrum. But heat hydrogen, and it produces this pattern of spectral lines. Here is the spectrum of sodium, dominated by the bright yellow lines. Looking at the sun, 19th century astronomers found familiar spectral patterns: hydrogen, the yellow of sodium, and many others, proof that objects in the sky were made of the same stuff as those on Earth. Astronomers also brought spectroscopes to eclipses with astonishing results. This was detected in 1868, the trace of an unknown element later named helium, from Helios, the sun. The next year, the American astronomer Charles Young saw a bright green line in the corona, evidence he thought for an element dubbed coronium. Young was mistaken. Instead of coronium, he had discovered something much more important. Atoms emit their spectral colors when heated, struck by energy. Helium can flash its strong yellow line. One of iron's lines is violet. But heat iron atoms to 2 million degrees and their atomic structure changes, and so does their spectral light. Now you can see the bright green line that Young observed. The green line is thus a thermometer. Wherever it occurs, the corona is 2 million degrees.
One idea about why the corona is hot is that it's just heated up by a whole string of firecrackers going off, one after another. Pop, 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 pop. They're too small to see in the normal kinds of pictures of the corona that we get, which are very fuzzy. But here at Mauna Kea, with the big telescope and the good seeing, we think that we can take pictures that show much smaller features.
Large magnetic storms pour some heat into the corona, but most coronal heating seems to take place on a scale too small to be seen in these artificial eclipse images. With his large telescope focused on a true eclipse, Labonte hopes to capture the smallest magnetic microflares ever recorded.
If we can see the corona just twinkling, turning on, turning off, turning on, turning off, then we have a real test that, yes, indeed, there are separate, identifiable, explosive events that are heating the corona. It's like when you drive a car. When you drive down the road, you drive smoothly, but in fact, the engine is making hundreds of explosions every minute in the cylinders. Boom, 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 boom. You don't think of it that way. It seems like it's a smooth motion, but it comes ultimately from these little explosions.
To track down these explosions, Labonte's cameras will take pictures here, looking for Young's pure green light, images of the corona wherever it is 2 million degrees. Taken together, the 4 eclipse experiments are designed to build a broad picture of the behavior of the sun's magnetic field. All are aimed to help resolve the mystery of why the corona is so hot, and what the hot corona may reveal about the workings of the sun itself. But the clock is ticking down now on the eclipse, and the scientists' attention has begun to shift. Atop Mauna Kea, the time for grand theory is over. From now on, it will be science in the trenches. Two days to go. Each experimental team wants to be ready by nightfall, leaving 1 day clear for emergencies. But the NASA team faces its worst crisis yet. Celeste has failed again, forcing the team to improvise against the clock.
Boy, that is flaky.
They first turn to their insurance policy, a smaller, less sophisticated backup instrument. Hurriedly, they check out the electronics in the backup detector.
Is that in the right place? We're just doing some final tests on it now before we mount it on the telescope to make sure that it can actually detect radiation. Since we've had so much trouble with these arrays on this trip, we just want to make sure before we go to a lot of trouble that this one's actually operating.
Like Celeste, the backup is an infrared detector, and the way to test an infrared instrument is to show it some heat, any heat.
Looks like it's seeing my hand. It's not acting right yet. This one is much harder to find, has a much smaller operating range.
The backup has its own bugs.
Are you changing anything?
Yeah.
I'll try it. Okay.
The team is running out of time. To rehearse their experiment, they must have one of their instruments on the telescope tonight. At the University of Hawaii Observatory, the scientists are performing their own instrument check. It's a little less sophisticated than the NASA version.
And nothing's falling out of the box.
And nothing's falling out of the box. No, not a single thing. Yes, listen closely and see if something falls out. And see what it catches on when it does.
The cameras are now ready to detect the green light of the hot corona, but Labonte continues to fret.
I guess we're always afraid of things that are, that are not in our control. I mean, things inside our control, inside the dome, we control it. If it breaks, well, we'll pretend we can make it better at least. Things outside, like the electricity and the clouds, the weather, that's the sort of thing you can't control. You worry about it, you can't do much about it.
There's plenty to worry about. The sky is about to take a turn for the worse. Volcanic dust from eruptions in the Philippines had raised fears. But now, as heavier clouds drift by, plain bad weather troubles observers more.
Not that we're having rain or snow or anything like that, but there's heavy cirrus. And so far, I haven't been able to get a good weather forecast to understand whether this is the beginning of a big storm that's coming in, or whether it's just a transient affair. But there's cirrus out there that's very heavy.
For our experiment, which is a high spatial resolution experiment, we want to get very high resolution images. Dust, the volcano dust, is not really something important. With haze, we could have very good seeing. But of course, if we have heavy clouds, this would be really catastrophic. It would be the end of our experiment.
Okay, stop there for a minute.
But right now, Kuchmi's experiment is on track.
Stop. Up slow.
The cameras have passed their bench tests. Now the team tackles the delicate task of mating the instrument package to the telescope. The cameras weigh just 250 pounds. But that's enough to unbalance the 250-ton telescope. Rebalancing the new configuration is the culmination of 2 years of work. It has been an endless day, but the NASA team has finally achieved a small victory. The backup instrument is at last operating properly. Celeste is still in the body and fender shop, but at least one of their instruments is ready to go.
Did you trust your doer to a weekend auto mechanic?
The backup instrument has much less resolution than Celeste, but it could take some data during the eclipse. Still, no one here will get to sleep anytime soon.
It's the end of a long day and a half.
Well, and the day is not over. It looks like we're going to be up all night working on the other instrument. So the sun's going down, but the day does not end.
Somewhere, Celeste has a loose connection, and the weary team must spend the night tracking down the failure. One day to go.
Well, there we are. There comes the sun. There's the focus. Oh boy, have we got sunspots. Holy shit, look at all the sunspots. Or rather, holy cow! I can't remember having seen so many spots on the sun at once.
Zirin can relax with his telescope ready to point at the sun, but the NASA group just keeps on going.
Which side goes up?
They too have built a special filter to protect their telescope from the full glare of the sun.
I want to cut away some of that tape. I think we do. I think we want to cut it away and maybe tape it at the top, the center, and on the secondary. But I think it'll be big enough.
It's almost the right size, but like any custom-made suit, the filter needs a few alterations, so the NASA scientists simply trim it to fit. In the grand tradition of eclipses, they're improvising, which is how they came up with the filter in the first place.
As I opened my lunch, I found that my lunch contained a new sample of material. It was a bag of potato chips from a local supermarket made in a material like this. And it was something that I hadn't seen before. And so on an off chance after lunch, I tested it. It was very good. It was the best material we'd found. It scatters the visible sunlight, so and does not scatter the infrared. So the telescope cannot form an image with visible light, but can form an image in the infrared. So here we have the equivalent of several hundred bags of potato chips, which were rescued from that fate to partake in our solar eclipse experiment.
The NASA scientists aren't done yet, for they still hope to repair the sophisticated Celeste for the eclipse. But those who can are taking it easy.
Now I'm at the school. We're staying overnight here because the eclipse is tomorrow morning. So we have to leave the school at 4 in the morning. So I think it's going to be a fun night, though. I think, they have like a festival outside or something. So I think it will be fun. Yeah.
The festival atmosphere peaks as the last waves of Eclipse Chasers invade the Big Island.
Trying to do this for a year now. We finally made it in. We've been trying to find this for a year now. We finally made it in. We just got this flight booked last night. This is incredible. My friends here, Ted and Joy, we've been trying to do this. It's amazing. We're going to be up for 30 hours straight, but this is absolutely worth it. I love
The visitors and local Hawaiians have a common cause, a prayer for cloudless skies on eclipse morning. It will soon become clear how such prayers get answered. But already there is one group that has cause to cheer. With hours to go, the NASA team has finally fixed Celeste's bad wire.
Now watch the screws on the bottom. Snout in.
They're betting it all. They've pulled their backup instrument off, and they're swapping the crash-prone Celeste onto the telescope for their one shot at the eclipse.
We realized that we had a chance, just a chance, of actually opening the door up, fixing the array, and cooling it back down just in time for the eclipse. And we thought as long as we had a chance, we might as well give it a shot.
The NASA team has just squeaked in under the wire, but now all the experiments are ready. It is the sun's turn to perform.
Let me see if this is gonna work.
4 a.m.
Should I tape this like right here?
Why is it gonna get in your way?
No, it's just so it could hold. So this won't turn. This thing's really loose, it's like an old one from the school.
Anna Correa and a local friend set up on an oceanfront golf course. The eclipse countdown has begun.
Does anyone know the contact point coordinates? Just to check.
Yes. 645, we fill with helium. I've got to remember, Dave's got to give me a guide rate of about 20. Okay, about 6:57 is the first time we can acquire the sun. That time, Dave's going to cut the phone line so we don't have any distractions.
Okay. We're ready.
Sunrise in about 1 minute. Huh? Really high clouds, huh? Just incredibly high.
5:51 a.m. Dawn comes late to Mauna Kea because of the abnormally high clouds in the valley below. There are 37 minutes to go to first contact. For the first time in their history, the giant telescopes maneuver into position to explore the sun.
Ten seconds to first contact. Mark.
Let's do it.
Great, come and open up the dome right now.
Here it comes. We're seeing real bright stuff.
There's first contact.
There's the contact.
Is that right? I thought first contact was 1635.
With the first bite out of the perfect round disk of the sun, the eclipse begins.
Yeah, we got it.
First contact confirmed. Okay, understood. Okay, we have first contact.
10 seconds. I was late by 10 seconds. What's the TV? Huh? You cannot do better.
Can do better.
Dre,
Yes?
please tell us when you're moving and when you stop moving and we can look.
Okay, I've stopped moving. Go ahead.
Okay, we got the line. Let me get the scale. Okay, why don't you take a look at it?
Yeah, I see it. I see it.
What are you talking about?
Did you move the telescope?
No.
Oh shoot, the cloud's covering it up.
No, Don thinks you're moving off. No, I'm not. Okay, hang in there. We can see the line just fine here.
You can see it?
Yeah.
Oh, good. Okay.
Yeah.
Hey, Dave, the telescope's coming apart. It's all right.
So the computations were right after all.
So we have the right date?
Yeah, we have the right day.
It's getting dark, guys.
Yeah, it is.
I hope it's because the moon's getting in the way.
The image is getting worse, so we are wondering if you are not a cloud right now. Some mist coming.
As the sun heats the clouds in the valley, they rise, racing the moon as both cover the sun.
It's covering it up. This thing's really getting to me. It's covered, right? It looks like something's coming. You know, like two things. So
you can't really tell if it's
on the right, is it? I don't know.
Oh, wait a minute.
It kind of looks like it.
Now I lost the place totally now.
It's the eclipse observer's nightmare. With 15 minutes to go to totality, the clouds top the crest of Mauna Kea's summit ridge.
The trick is that at some point, if it starts bringing fog into the dome, they got to close the dome so it doesn't put wet water on the telescope.
A ton of cirrus?
It's dispersed, it's not filled.
The deepening clouds seem to slow down time as the observers look for a break.
Humidity's coming down. This fog may well be gone in a few minutes.
As the moon covers the sun, the temperature drops just a little. The clouds sink a few hundred feet below the summit. It's enough.
be looking at the sun in a few seconds. Sorry, a little late. Dome's taking a while. Okay.
Go. Here, I got it. Got sun.
Done. There you boy. There boy. Steer her in. Nice region.
Very small. Okay, you can go. We have total eclipse of the sun over Mauna Kea.
Is the camera working?
Yeah.
Okay.
It's going. It's running.
Okay. Let's go outside and enjoy the view. Look at that! Wow! Incredible!
On the coast, it's a different picture.
And here goes my project. I mean,
I know.
who knows? Maybe God will listen to us and help us out here.
What, it's a huge prominence.
Yeah.
Do we want the prominence?
You'll get it.
Oh, hey, this is great. We got prominences the size of a Buick.
Oh, nice!
But
the prominence.
Isn't that was just stunning. Be great. Just stunning.
Monster prominence.
Jeez. Well, it's not what I was anticipating looking at.
Never did.
I was going to try to dodge that like a bullet, but...
But we got some nice low loops. Remember those?
yeah, I
Green
mean,
ones.
it's got
Great.
a lot of good
Very
loops
nice.
down there. We got a lot of stuff to look at, so... We'll see.
We'll see.
Still about 10 seconds.
Okay, Dome's safely out of the way. I'll continue tracking
Right
the
to
sun.
hard disk. Got it.
Okay, finished.
Hey! Even my goddamn movie camera worked. I can't believe it.
Amazing.
Okay, go on. Put the solar screen. Take the telescope out.
Voilà, le voilà.
Out,
Voilà.
everything. Finish. Solar eclipse is finished on Mauna Kea. Vous étiez sur le soleil.
With the end of totality, there is still an hour of partial eclipse to go.
Watch, the second we leave, it'll open up. It's always like that.
Well, how's it going?
Well, slowly, it appears. But I got a few shots of the partial anyway. Kind of disappointed.
Well, you look happy from here.
Yeah,
Huh?
well, I guess I am. I gotta make do with what I can now. Get the last few phases of this thing.
like about this stuff?
Well, it's a chance to get in touch with the universe, and today was a chance to get in touch with part of life called disappointment. Trying to teach the kids that lesson, but it didn't go over very well.
This calls for celebration. I think we have a can of passion guava juice over here. Let's break it out. Well, we got pictures to look at. We got pictures to hang on a wall, right? That was what
That's
really
all
mattered.
that counts.
You got to
Show
have
me
the
a grandchild, right?
you got to have the moose head to hang on the wall,
That's
right?
it. What do you think?
And here is the moose head. The moon is the black sliver on the left. Solar prominences shoot out from the sun. But the team is still searching through the data for the tiny explosions that could heat the gray fog, the corona, to its green line temperature of 2 million degrees.
It went as well as it would have gone if we had had no trouble, because everything we tried to do went exactly the way we tried to do it. We made no mistakes. Now we just have to sit back and look at the data and hope that what we want is in there.
So I am going marlin fishing and to the beach for 5 days, and I'll worry about the data after that.
But there was nothing to worry about. The NASA team detected the infrared emissions of the surface of the sun. Here, the hot pink center is the digitized signature of their infrared wavelength at totality. It is the information they need to measure the strength of solar magnetic fields in the mysterious region above the surface of the sun.
I'm not too disappointed now because at least I got a few pictures, so my project isn't totally ruined. You know?
Yeah.
If I hadn't gotten any pictures, then I'd be on the floor crying. I mean, that's my whole point of being here. So, keep praying.
It is a tribute to the power of prayer. Anna's pictures, taken during the partial eclipse, provide enough examples of the moon's passage across the sun to allow her to study the Earth's rotation. She will work on the project for her next 3 years of high school.
Some of the things didn't go perfect, they always screw up a little bit, but it was good. I can't wait to see the data.
This is what the sun looks like to a radio telescope, and this trace contains an important discovery. It reveals an inner atmosphere 4 times more densely packed than predicted. It is a startling finding, one that could help explain the abrupt change between the 6,000-degree solar surface and the million-degree corona.
Well, we were a little bit anxious, I would say half an hour before, because this cooling, started, and well, you never know what could happen even at 4,200 meters.
This is what did happen. The Canada-France-Hawaii team obtained some of the best photographs ever taken during an eclipse. These images of the inner corona contain the finest details ever recorded in the solar atmosphere. These are sights that literally no one has ever seen before. For 4 minutes on the morning of July 11th, 1991, the moon and sun crossed paths. It was, as those who saw it knew, the eclipse of the century.
production of WGBH Boston. Funding for NOVA is provided by Johnson & Johnson, the signature recognized around the world for commitment to quality healthcare products for the entire family. And Lockheed, America's aerospace company, supporting math, science, and engineering education for national technology leadership. Major funding for NOVA is provided by the Corporation for Public Broadcasting and by annual financial support from viewers like you.
This is PBS.
Next on NOVA. Hurricane Gilbert rips across the Caribbean, heading for the Gulf Coast. Where will it hit, and how much damage will it do? The unpredictable character of nature's most powerful force is slowly yielding its secrets to science. Journey into the eye of the storm for an up-close look at the killing power of the hurricane. That's next time on NOVA.
For a transcript of this program, send $10 to this address or call 1-303-831-9000.